All right, this video is going to take us through what we want to learn about with the with matter. All right, so this whole unit, this is going to be a little bit different. This whole section is all going to be focused on chemistry. All right, and so we're going to really look at these three areas when we're talking about how matter. Let's get matter. That's just the stuff that things are made of. How it can be organized, how it can be classified, etc. So the first thing we're going to do in this video is talk about homogeneous and heterogeneous. Classifying matter is one of those two categories. We will also look at the physical and chemical properties of matter and acids and bases. Those will be a little bit later. All right, so all matter can really be broken down into two categories. All right, that should say a pure substance. So matter can either be a pure substance, which is considered then, or a mixture. A pure substance, now this is a lot more rare. A pure substance is much more rare than a mixture. Most things that we'll see are mixtures. A pure substance would be things like an element, all right, or a compound. All right, so if it's a pure substance, and we'll go through how to break this down. If it's a pure substance, it's either going to be an element or it's a compound. If it's a mixture, it's either homogeneous or heterogeneous. All right, and we'll break that down as well. All right, so really all matter can really kind of fit into one of these categories here. All right, so a pure substance, all right, its definition, it's the exact same composition. It's made up of all the same stuff. All right, that's what that means. All right, and so an element is an example of a pure substance. It's all made up of the same type of atom. It can't be broken down into a simpler substance while maintaining the properties of matter. All right, and so what that means is you can't get any more basic than an atom. It's all the same, of an element. It's all the same type of atom. All right, and atoms are just the building blocks of matter. All right, but if you tried to reduce an element any simpler, it would basically just become a typical atom. All right, because elements are in their most basic form. All right, and now elements a lot of time, and this is going to be important that we talk about, a lot of times elements are written in chemical shorthand. All right, elements are typically written as their chemical symbol. All right, so sometimes this can be confusing. It's like, why are there a bunch of letters up here? Well, think of it, it's kind of like math. I know I said we're going to do a lot less math this quarter as opposed to last. But if you think about it, in math, you don't see problems like 1 + 3 = 4. You don't see things spelled out. You just see the numbers, the numeric representation of those numbers. It's a lot easier to look at. We do the same thing in chemistry. All right, so instead of saying 2 hydrogen atoms bond with 1 oxygen atom, produce water, all right, we just write H2O. It makes it easier, all right, to do. So every element has its own unique chemical symbol. And some of these, a lot of times we're going to spend time on just the first 20 elements. And a lot of these make sense, like H represents hydrogen, He represents helium, lithium. But some of them, every now and then, you'll get to some like potassium, where you're like, K is potassium? Well, you can't make it P because that's phosphorus. So a lot of times when you see these random ones where it's like, whoa, that's not close. What's happening there are Na. I skipped right past sodium. Na is the same thing. You can't say S because it's sulfur. What they do is they use the Latin word, all right, for these, like iron is Fe. All right, for ferro, it's Latin for iron. So they'll use typically the Latin form of the word, but it still is the representation of that word. All right, so these are chemical symbols that represent the individual elements. Like I said, we're going to focus on the first 20 as we get into atoms and the periodic table and things like that. All right, a pure substance, so an element is just when it's just everything is the exact same. It's all one substance. So all hydrogen atoms just have 1 proton, no neutrons, one electron. All right, so it's all the same. A pure substance is when those elements combine together. All right, so it's a pure substance. It's when they come together. Now, and they have a fixed composition. So like all water molecules have exactly 2 hydrogen and 1 oxygen. All right, so it's the same. It's the combination. I have a combination of hydrogen and a combination of oxygen. All right, glucose, I've got 6 carbon, 12 hydrogen, 6 oxygen. I've got the same, it's made up of the same stuff. All right, so it's still, the reason why it falls into a pure substance is because it's still made up all the same stuff. It's a fixed ratio. That will always stay the same. Okay, so a compound, two or more simpler substances broken down into one. All right, and so the easiest way, so when I ask you, is this classified as an element or a compound, the easiest way to look at it, because every element is characterized by a capital letter. It starts with a capital letter, and then sometimes it's preceded by a lowercase letter. But that capital letter, and I'm going to be very specific on this, that capital letter signifies a new element. So when we write like chemical formulas and stuff, you have to write the first letter is capital, the second letter is lowercase. Okay? Like this is Al, that's not AI, that's Al, aluminum. You can't write a capital A and a lowercase l. And a capital L. All right, it has to be a capital A and a lowercase l. So it has to be, the first letter has to be a capital because that signifies the new element, and the second letter has to be lowercase. All right, so I'm going to be pretty particular about that. And it really helps us to identify, because like if I wrote CO, like CO here, that's carbon, capital C. You might say, well, that seems kind of picky. A capital C and a capital O, well, that's carbon and that's oxygen. But a capital C and a lowercase o is an element called cobalt. So a CO like this and a CO that's lowercase, the O is lowercase, they mean two different things in chemistry. So you got to make sure that you're writing it as, if it's one element, a capital C, a lowercase o. But if it's two elements, you got to make sure they're both capitalized. All right, so because they mean different things in chemistry. All right, so and then if we're classifying these as an element or a compound, which I'll do, basically all I want you to do is just, all you got to look at is, are there two capital letters? If there's two capital letters, that means there's more than one element that's bonded together. All right, so that's going to be a compound. If there's only one capital letter, then it's an element. All right, so carbon dioxide, that's a compound. Gold, one capital letter, that's an element. Water, H2O, I got a capital. I got hydrogen and oxygen bonded together, compound. Copper, Cu, I don't know why I put that in parentheses, but hey, there we go. That's an element. NaCl, I've got two capital letters here. I got Na is sodium, Cl is chlorine, which this stuff fascinates me, by the way, because you have sodium. A lot of times we call salt sodium. Sodium is actually a metal. It explodes on contact with water. Chlorine is a yellow, greenish, poisonous gas. And when they react, they produce an edible crystal we put on French fries. It doesn't make sense. I'm going to talk about this more later. But it fascinates me how just the arranging of electrons, moving one electron from one to another and forming a bond, how it can create an entirely new substance. Shiny metal, poisonous gas, but when they come together, they create something we put on French fries. It's weird. But that's obviously a compound. And then hydrogen gas, you might say, well, there's two there, but we still only have one capital letter, so that's just going to be an element. All right, mixtures, it all looks like one substance. There's two types of mixtures. There's a homogeneous mixture and a heterogeneous mixture. Homogeneous, that root word, a lot of times, and this is going to sound weird, but a lot of times it's easy to think of when we're trying to characterize mixtures. All pure substances are homogeneous as well, because it's all made up of one substance. It all looks like one substance. But mixtures can also be homogeneous. All right, that word homo, a lot of times sounds weird, but it's easy to think of it in terms of sexuality. It looks like one substance, but it's a mixture of different ones. So homogeneous mixture, like a homosexual likes somebody that looks like them. It all looks the same. They like someone that looks the same as them. A homogeneous mixture, it all looks the same. It all looks like one substance, but it is a different substance. It's a combination of different substances. So homogeneous, it all looks like one substance. How is it different from a compound, you might say? All right, well, the reason why this is not considered, this is a mixture. So a mixture is different from a compound because a compound is chemically bonded together, whereas mixtures are just physically combined. Are, not or. Mixtures are physically combined, whereas compounds are chemically bonded. All right, so mixtures can be homogeneous, where they all look like one substance. They're physically mixed together, but it's actually two different substances. All right, and then the other type of mixture is a heterogeneous. Once again, think of it in terms of sexuality. A heterosexual, you like somebody that looks different from you. A heterogeneous mixture, it looks different. You can see the different parts. Okay. It's a combination of two or more substances that are not uniform. They're not the same. It looks different. All right, and so if we were to classify matter, once again, this is all matter. It's not just like scientific things. It's like got a bunch of junk up here. All right, homogeneous or heterogeneous mixture. All right, well, that all looks like one substance, right? You might say, well, how is that not a pure substance? Well, it's not. It's a mixture of what is it? Iron and zinc. I don't remember what the mixture is, but metals can be mixtures. They become alloys. You melt down the metal and then mix them together. All right, but it all looks like one substance, so that's a homogeneous mixture. Now I got two pops up here. You might say, well, that's weird. Why has he got two pops? And why they just go into two different categories? Because this is it can depend. So when you have a sealed bottle like this, it all looks like one substance, right? So it all looks like one substance, but oops, went the wrong way. So when it's sealed like that, it's a homogeneous mixture. But once you crack that open, you can see the little bubbles, little carbonation. I can see the liquid. I can see the gases that are coming out of it, the carbon dioxide that's being released. Then it becomes a heterogeneous mixture. So sometimes the same substance can be classified as two different things. Okay. Pizza, obviously you can see all the different parts to that. All right. Tap water. You might say, I thought water was a compound. Yeah, but tap water has other things in it. It's got like fluorine in it mixed into it. So while even though it all looks like one substance, it all looks like a compound, it's got other minerals and other things mixed into it as well. So that makes it all look like one substance. So it is a homogeneous mixture. Tap water. Chex Mix, obviously you can see the different parts. And then black coffee, it all looks like one substance, but it's not. It's a mixture. All right. And so that is how we classify matter, organize matter, just based on whether it's a homogeneous, heterogeneous mixture, an element, or a compound.